Okay, now we're going to look at phase shifted trigonometric functions. So my amplitude is 2, my period 2 pi divided by 1, 3. There is a phase shift. Take this and set it equal to 0. So the original x and y will be provided. You have to show on it what's happening. And let me extend that just a bit. So the way it works, I would start with my shifts first. I have a shift of pi over 4. I'm going to say pi over 4 is right here. Sometimes I have to adjust that a bit. So this is my new origin, x equal pi over 4. From here I'm going to move my amplitude, so 2 units above and 2 units below, and I label that clearly. And this is y equal 2 and y equals a negative 2. Now we have an issue. Since it's shifted, I'm not sure how to stretch it. I can't stretch it like I normally do because I'm not sure whether this graph runs this way, or this way. So this is what I'll do. I'll figure out the point, meaning I'll look at a cosine wave. I know a cosine graph looks like this. So all what I need is to figure out where this point is with reference to that. And I know this is 1/4 of the period. So if I take 1/4 of the period, but with the shift, all what I have to do is add the shift to it. And that tells me where is this new location with respect to this shift. So I know the graph starts right there. So if I take pi over 2 plus pi over 2, that's pi. To make it matching, I need to put it over 4 to see how that goes. So this is 4 pi over 4. So this point, if this is pi over 4, this is 4 pi over 4. Now that I did cut this a 1/4 to right there, so I know where to go. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is right there. So I know how this stretch goes. So this is a bit going to be bigger than I anticipated. So what I'll do, I'll resize the graph. That is, I will do everything accordingly, except since I know it's going to run really long, I'll cut this in half. And by doing that, I'm rescaling the graph before I start, which is very helpful. This is x equal pi over 4. And I know at 4 pi over 4, so if this is 1 pi over 4, 2 pi over 4, 3 pi over 4, this is 4 pi over 4. The graph is going to look like this. So obviously I went from pi over 4 to 4 pi over 4. So I know there are 3 of those. I go 1, 2, 3, and I know exactly where that's going to touch. 1, 2, 3, and 1, 2, 3, and that's a full cycle. So the graph looks, and the labeling, 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4, 8, 9, 10 pi over 4, you could reduce, 11, 12, and 13 pi over 4. Not only do I know to the right how the graph look like, to the left, if this here was 3 of them, I went from 1 pi over 4 to 4 pi over 4, so I added 3 to the top. To the left, I subtract 3. That is 1, 2, 3, and I know exactly where this graph, and this graph turns out to cross right there. And 1, 2, 3, that's the second point. 1, 2, 3, and the last point is right there. and there's 2 cycles. I'm going to request a cycle to the right and a cycle to the left of the starting point. So that's something you should start getting used to. And that's the only type of graph I'm willing to accept, so make sure that you're doing that in the homework so you practice for the exam. Now let me clear this one up. Okay, now first one is always the messiest. Let's see the second one. 1. I have an amplitude of 2. I have a period of 2 pi. I have a phase shift of x plus pi over 6 equals 0, which means x equal negative pi over 6. And let me stretch that out because I'm not sure how that's going to go. So again, I go to my shifts. I start with negative pi over 6. Let's say it's right there. Again, sometimes I have to readjust that. So if this is x equal negative pi over 6, amplitude of 2, I move 2 units above it and 2 units below it. And I label that clearly. Y equal 2 and y equals a negative 2. A graph of a sine wave starts at the origin, so I am aware that the graph starts right there. Again, the same problem. I don't know if the graph is going to run this way, or this way. So what I do, I'll figure where that is, meaning I would look at the graph of a sine wave. The graph of a sine wave looks something like this. This point right here is right there. If this was at 0, I know where this point is. This will be at 1/4 of the period. The period is 2 pi. All what I have to do is add the shift to it, and that tells me on the shifted graph where that is. And that's how you do every problem. So this is pi over 2 minus pi over 6. All over 6. 3 pi over 6 minus pi over 6 is 2 pi over 6. I wouldn't reduce because I need the denominators to be the same. So this tells me, instead of this point being at pi over 2, on this shifted graph it's at 2 pi over 6, and look at this. I've already measured this to be 1 pi over 6, so all what I have to do is go 1, 2. That's where the graph is going to cross or touch the amplitude. So the graph really looks like this, and the graph will be scaled properly and labeled properly. So I know that it took 1, 2, oops, let me not do that, otherwise you might confuse it. So here, if I know it took 1, 2, 3, well, 3 more, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So this will come down, touch right there, 3 more. I don't like that graph, I need to look a bit prettier. So if you sketch the whole thing, it will look smoother. There we go. And to the left, 1, 2, 3. Of course, you could rescale this if you want. You could make this one, but I already did the work. Might as well. 1, 2, 3, and 1, 2, 3. That should take care of the entire graph. 1, 2, oh boy, and 3. All right. I should have shrunk that. Maybe that's what I'll start doing. I'll start cutting those in half. That will be easier. So if I was to go ahead and do that here, otherwise I'm going to run out of space. So if I am to say this is negative pi over 6, maybe that's what I'll start doing. That is negative pi over 6. So 3 more, 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. There. It looks a lot nicer this way. And to the left, 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. let's see how this looks. Comes down, comes back up. So 3 is right here, and the last 3 is right there. And I need this to be a smooth curve, no sharp changes. So there. And the labeling, well, I know this is negative pi over 6, and this was at 2 pi over 6, 1, 2, right? So we added from negative pi over 6 to 2 pi over 6, we added 3, add 3 more, 5 pi over 6, add 3 more, 8 pi over 6, and add 3 more, that is 11 pi over 6. To the left you subtract negative pi over 6, minus 3, negative 4 pi over 6, minus 3, negative 7 pi over 6, another 3, and another 3. You could reduce those if you wish. Now, if you ever measure this, meaning one full cycle, take right minus left, 11 pi over 6 minus a negative pi over 6, that would be 12 pi over 6, which is 2 pi the period. You don't have to, but you could always measure that if you wish. Let me shift this one down and proceed to the next problem. So one, my amplitude is 4. 2, my period is 2 pi divided by 3/2. I'm going to multiply by the reciprocal. So that is 4 pi over 3. That's the period. I have a phase shift of 3x over 2 plus pi over 3 equal to 0, which indicates that 9x plus 2 pi equals 0, or x equal negative 2 pi over 9. I'm choosing bizarre numbers so that you could see how this actually works under any circumstances. And 4, we have a vertical shift of y equal 2. So this graph has pretty much everything. Let's do that. Here we go. So if I am to go to my shifts first, I have 2 of them. I'm going to move negative 2 pi over 9. Let's say this is negative 2 pi over 9. Let me play it safe. X equal negative 2 pi over 9. I'm going to have to shift the graph 2 units up. And let's say this is 1, 2. So pretty much this is my new origin. Y equal 2. I'm going to do everything starting at this point. I'm going to move 4 units up. 1, 2, 3, 4. I labeled that clearly. I started at 2. I went up 4. That's 6. And I go down 1, 2, 3, 4. I started at 2. I moved down 4. That's y equal negative 2. And the same issue again. The graph starts right there, but I'm not sure how it's going to behave. I could figure out where that point is before I start. A traditional graph without any of the shifts would look like this. This would be 0. This would be pi over 2. Well, 1/4, I'm trying to figure out where this is on this graph. 1/4 of the period plus the shift. So the 4's cancel out. That's pi over 3. So all over 9, 3. 3 minus 2 is 1 pi over 9. So I went 1, 2. This point is going to happen at 1 pi over 9. There is 1 pi over 9. And once you get that part, you get the whole graph. Because this is negative 2 pi over 9. I went to 1. You could label it here. You could label it on the x-axis. It doesn't matter. So I went from negative 2 pi over 9 to pi over 9. That's adding 3. 1, 2, 3. Add 3 more. 1, 2, 3. 1, 2, 3. And 1, 2, 3. That's the cycle to the right. And to the left, 1, 2, 3. 3. So everything moves in 3's here. And the graph, again, if you do it one shot, it turns out to be a lot nicer. And the labeling, again, I know how that works. Negative 2 pi over 9 to pi over 9. Add another 3. 4 pi over 9, add another 3, that is another 3, 7 pi over 9, and another 3, 10 pi over 9. To the right you add, to the left you subtract 3 from 2, that's negative 5 pi over 9. Subtract another 3, negative 8 pi over 9, another 3, negative 11 pi over 9, another 3, negative 14 pi over 9. And that's pretty much how all of these graphs go. I have one more to go, and then a couple of going backwards. If I look at this graph, well, let me put the grid. There's always a grid. So, and just for the beauty of it, let's make that a minus. So, 1, my amplitude is 1. 2, the period is 2 pi divided by 2, which is pi. 3, I have a phase shift. Set this equal to 0. X would equal negative pi over 4. 4, I have a vertical shift of y equal 2 right there. And 5, we have a negative, so we need to reflect. So I start with my shifts first. Negative pi over 4, I'm going to say it is right here. And I label that clearly. X equal negative pi over 4. Go up 2 units, 1, 2. Y equals a 2. Amplitude is 1. Let's go up 1. You know what? Since it is not that far, let me scale that as 1, 2 units. So scaling is important for you to see the graph, but you could do it any way you want. I'm going to move a unit above it and a unit below that. And the graph is going to be between y equal 1 below 2 and 1 above 2. Got it. The graph of a sine looks like this. It's going to run down. So normally a negative cosine would look something like this. I'm trying to figure out where this point is with the shift. So I'll take 1/4 of the period is pi, plus the shift. I'll get 0, which means the first point is actually right there. So, no problem. 1, 1, and 1. Here I could have really stretched it out a bit. No big deal. If you do this on the exam, no need to you just need to label. So if I went from negative pi over 4 to 0, that means I added just 1 to the top, add another one, add another one, and add another one. To the left, this is negative pi over 4, subtract another one, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, and negative 5 pi over 4. Of course, stretching this will make it look better, but no big deal. Now, if I gave you the graph, can you give me the equation? If I told you, here's a graph, tell me what the equation for that graph is. Well, I know this is y equal a cosine of x. Cosine because it starts at 2, so I know the amplitude is 2. But it should be really not x, it should be bx. Let's see what the period is. The full cycle to this graph is 2 pi over 3. So I know if we take 2 pi divided by b, we'll get the period, which is 2 pi over 3. If I solve cross multiply, 2 pi b equals 6 pi, divide by 2 pi both sides, and that's a 3. So that's my answer. That is the equation for such a graph. And if I went to the second problem, I noticed that the second problem is a sine wave because it starts at the origin. And I could figure out what the full period is. So this is y equal a sine of bx, there's no shift, y equal, I notice we went up to 3, the sine, and how does this work? The period is always 2 pi divided by b. Since b is 4 pi, if I cross multiply, divide 1/2 x, or x over 2 will do. And if I look at the last problem, I'll notice this graph is shifted. This is a graph of a sine wave. Bx plus c. It's kind of hard to really pinpoint this. So what I do, I play it smart and I put the period up front. That will make life a lot easier. Well, the amplitude, if this is a sine wave and this is the cycle, I know that the amplitude is 2. I need the period and the shift. If I write it this way, I know they shifted that pi over 6 to the left. That takes care of it. And the period is 2 pi divided by b. And what's the period? If you take pi over 6 minus a negative pi over 6, that would be 2 pi over 6, which is pi over 3. That is the actual period. It is pi over 3. If you cross multiply, pi b equals 6 pi, so b equals 6. So if I put the 6 up front, this is really simple. If you really want to impress, and you don't have to impress anybody, I'm impressed if we get it this far, you could also say y equals twice the sine and distribute that in. 6x plus pi, that will have the same effect. You don't have to do that. And that's pretty much it for this section.